All right, to start the chapter on infinite series, we're first going to talk about, what is a series? Before we can talk about series, though, we need to talk about sequences. So what I've written out in front of me is a rule for a sequence. All a sequence is an ordered set of numbers following a constant rule. So here the rule is, if we want the nth term of the sequence, we have to multiply n by 2 and subtract 1. The first 5 terms would be, here 2 times 1 is 2, minus 1 would be 1. And so when n equals 2, this is 4 minus 1, this is 3. When n equals 3, this is 6, so 5, 7, and 9. These are the first 5 terms of the sequence. And so what a series is a sum of a sequence. So instead of commas here, we're going to have additions. Whereas sequences will give you a list of numbers, series will only give you one resultant number. Sequence is 1, 3, 5, 7, 9. But the series here is 1 plus 3 plus 5 plus 7 plus 9, which is 24. Now we're going to talk a little bit about notation. So you may remember this symbol from chapter 4 when we talked about Riemann sums. But you might notice this one is missing a few things, namely here on the bottom and here on the top. So on the bottom here is what's called the index of summation. And so that basically means the variable that we're going to use to count. Here we're using n as the integer counter to determine what the next terms are. So our index of summation is n. Now we have it equal to what we're starting at. So here we started with the first term, so we have n equals 1. So this altogether means we're counting with n starting at 1. On the top is the number of terms you're summing to. In this case, we summed 1, 2, 3, 4, 5 terms. So this would be 5. Altogether, this reads, we're summing the sequence a of n using n starting at 1 up to 5 terms. But throughout the vast majority of this chapter, you won't see numbers up here. You'll instead see infinity. This is a common representation of the expansion of this series up to the nth term. That's a very basic introduction to series.